is finding the distance between the two strings which are passed. Generally, it is used whenever we are trying to search something, and when we get something from Google. Do you mean this, or did you mean this? So the meaning is something like whenever even we are typing on mobile, then that time we come to know that if I want to type say YOU, and then I type YUU. So it tries to autocorrect me and it tries to give me the correct string in front of me. So there, in such cases, actually this Levenshtein distance is used. This is the term which is used mostly in information retrieval, and it is also why is it used so much? Because when you try to retrieve the data from any search engine, and whenever you type something, then that time you expect that your word would be auto corrected, and accordingly you will get uh, the search engine would get the correct idea to find out what do you mean. So this Levenshtein distance is L and D are the two we can say two strings, and we are going to find out the difference between or the edit distance between the two strings in such a way that if there are two strings say test and tent, then what is the difference between the two? TE and TE are same. If I'm talking about test and then tent, then TE are same, but then there is a bit difference between here in the third character. You can see in both the strings you can see the difference. So by one letter there is a difference edit distance between the two strings, we can say so. So we are going to find out the example and we are going to write down the algorithm, the Python algorithm for the same. So it's something like it is distance is the number of deletions, insertions, or substitutions required to transform S into T. And here uh, S and T are the two strings, and we are going to find out the edit distance between the two. So if there are two strings, S is test and T is test, then obviously the difference between the S and T would be 0 because both are similar. But suppose if I talk about say some other string and they are maybe S in S there is test and other is tent, as I said told you earlier. So one substitution from S to N. So here there is S and here there is N. Otherwise both the strings are same. So it is one substitution or one change from S to N would be sufficient to transform S into T. So now we are going to see the algorithm for the same in Python. So let's have a look at it. Actually, this is the algorithm which is found out by Levenshtein, the scientist Levenshtein, in 1965. So he was a Russian scientist. So by his name, this particular Levenshtein distance or edit distance is written. So we are going to write down a function, say LD1, Levenshtein distance, and then we are going to find out the difference between the two strings, and we are going to write down the function in such a way that so here we can find out that if S is empty and even if I want to check whether T is also empty, then length of T would be obviously none, or maybe we can say 0, and return it is going to return S as for it S also none or 0. So here it would be 0 if I'm going to check the value bit of T. Okay, now obviously if the value of S and T are 0, if no characters are there, when we try to print S equal to is S equal to double quotes and no characters are there, if I try to find out the length of S, it would be 0. So in the same manner, if I try to find it out in such a way that S equal to S of -1 equal to T of -1, so I'm trying to compare the characters from the last character of both the strings. So it would be cost equal to 0, or it would be cost equal to 1. Because we are going to start from the last character. If both the strings checking whether what is the difference, then we can find it out. This cost is nothing but a type of flag we are using. So now we will try to compare the characters from the second last character by taking one by one character. So it would be something like we are going to call this function ld1 in such a way that this ld1 would be second last characters of s and t would be taken. So sorry, second last character of s would be taken. It would be compared with t, and as it starts from 0, we are doing here +1. So how we try to find out the second last character of s and t from the beginning? +1. In the same manner, we are going to try with for sh string, the first from the first character and second last character from second last character of t, and +1 because we are starting from again 0, because we always, if suppose I have a string test, then t would be, the first t would be at 0th position, e would be at first position, s would be at second position, and t would be at the final t would be at on third position. So in the same manner, it is going to get executed, and it is going to add this particular cost. The cost would be nothing but either 0 or maybe 1, because if the strings, the second last character of both the strings are not same, then it would be 0, otherwise 1. So it is going to get calculated, and then we are going to find out, return the value of result. Now I have to print that Levenshtein distance in the function. So this ld1 has been called, and I'm talking about, say, promise and promise. So I can try to find out the distance, edit distance between the two. So let's run the program. You can see here the distance is 1, because we have understood that there is s and there is c. So otherwise all the characters are same. In the same manner, if I say pro and promise, then we can try to find out what is the distance between the two. So obviously it will be 4, because the thing is MICE is different over here than this pair. So in this manner, we try to find out the Levenshtein distance concept, and generally it is applicable to whenever we are searching on any search engine, and when we type any wrong spelling and it suggests us that do you want to type down this particular spelling, or whenever we are typing something on Google on our mobile, and then it tries to autocorrect us, then that time this particular fundamental is used. Thank you very much for watching my video. Do subscribe to my channel Madhavi2303. I'll get more and more videos on information retrieval. Thank you.